parametric equations are. So let's say I'm working with a two-dimensional space. So any point in a two-dimensional space has the x coordinate and y coordinate. Once you put the coordinate charts on, the coordinate chart on, right? You have like where the origin is, and then you have the x direction and y direction. Okay, so now imagine that you are on a two-dimensional, or there's a moving object on a two-dimensional plane, and now this is a moving object, so its position changes as time moves on. So we have now an extra variable called t, and this t is gonna be in general called as parameter. All right, so at different time you have a different location, and location is being described by coordinates x and y. So what does that mean? As t changes x, the x coordinate changes. As t changes, the y coordinate changes. So we have x being a function x of t, like that in general, and the y being a function y of t in general. Okay, and then I'm gonna tell you like, oh, what is the range of the t variable? So this is just a very general idea. Let's give you a concrete example. Let's say x equals t and y equals 0, and t is going from, let's say, 0 to 5. Okay, so now you see when there's a dot over here, when t moves, the time moves, and then you can see the trace is like along the x-axis is like purple value. Okay, it's a little bit hard to see, so let me change the equation. Let's say y is equal to 1 all the time, and let's do this again. Okay, now you can see. So at t equal to 0, you are at x equal to 0 and y equals 1. And as time goes on, the y coordinate by the definition stays at 1, and x continue moves forward. I can play this a little more. Let's say I have x being cosine of t and y being sine of t, and now what do we have? Ooh. You see, I go from when t equal to 0, I have cosine 0, sine 0. So cosine 0, sine 0 is 1, 0. And as t moves on, you can see it gives us a curve like this on a two-dimensional space. Okay, it stops here because I put t max being 5. I can do 10. Then I'll keep going and circles it back. Okay, so in this case, it's a special case. You can think t is the angle theta that we use for trig functions. Okay, so this is another example of a parametric equation. So when you have a plane curve and the x coordinate is defined as x of t, y coordinate is defined as y of t, t is a parameter, then the x of t and the y of t is the so-called parametric equations. Let's do something more interesting. Let's do plus t squared, and let's do plus 3t and see what happens. Okay, so it starts from here and goes way up. I can see where it is, so let's zoom out. Zoom out. You can see that it travels like that and goes away. Let's zoom out again and goes like that. You can see that's how it moves. Okay, so now you have the idea what the parametric equations are. Okay, so it means I'm trying to use a parameter. It could be named t, it could be named s, or theta doesn't matter, a third input variable, and you use this variable called the parameter to describe the coordinates x and y. Okay, parametric equations.